Alright guys, let's solve the problems. Example 8.1. The uniform crate has a mass of 20 kilogram. If force, we have a pushing force. If there is a 80 Newton pushing force applied to the crate, and there is an angle, so you have to understand that there is a horizontal and vertical forces, because we can decompose this diagonal force into x and y axis forces. Determine if it remains in equilibrium. That means you have to decide whether this crate will move or not when the coefficient of static friction, which is mu s is equal to 0.3. Okay, so we have to decide whether this one is going to be moved or not moved. Let's solve this problem together. So this is basically we can use same approach what we usually done so far. Power cable. So first thing first, we have to draw the free body diagram. Okay, so here we have a floor, we have a crate, and this is the dimension. And you know what? There is a weight. This one has a uniform density, so the center of gravity should be in the center. So there is a weight. It's 20 kilogram times 9.8 meter per second square. So that is 196 Newton. Okay, and another one is there is some diagonal pushing forces. So we can decompose this force into x-axis and y-axis. So x-axis force and the y-axis force. So this one is 80 cosine 30, since this angle is 30 degrees. For the vertical one, it should be 80 sine 30. Okay, which is downward direction. Before we start to solve the problem, let's decide our orientations. Right hand direction is positive x, and the upward direction is positive y. And we can think about there should be frictions. Okay, there should be some friction. We don't know. This is a frictional force. Another one is normal force. We don't know how much distance is different distance from the middle. We don't know. This is x meter, but there is a normal force. Okay. Now let's solve the problem. Moment equals 0. Let's solve the x-axis forces. So we have a force 80 Newton cosine 30 degree, which is a positive, and we have another forces along with x-axis, which is negative frictional force, minus f. This one should be equal to 0. Okay. For the y-axis, we have a negative 80, which is 0, sine 30. We have another negative one, which is weight of this crate, and another one is normal force. This one should be equal to 0. And we can calculate the moment. Let's choose point here, point O, moment at point O should be equal to 0. So for example, this one create the clockwise rotation, this one create the counterclockwise rotation, and weight create another counterclockwise rotations. So we can write here cosine. Oops. Cosine 30 times 0.2 meter, and this one is clockwise rotation, so minus plus 89 30 times, we don't know the distance, but let's say this is the meter, right? This is the meter, so half, that means this one is 0.4. This one is 0.4. Okay, so 80 sine 30 times 0.4 plus x. Okay, since this one creates counterclockwise rotation about point O, so it's positive. Another one, we have a weight. Weight is 196 times x meter, which also create counterclockwise rotation, so it's positive. This one should be equal to 0. So it seems like we have one equation to solve one unknown, which is x here, so we can find x here. Another one is, okay, we can find another unknown forces, which is the normal force from the second equation, and the last equation we can find frictional force. Okay, so the question is, if we push this amount of force to this crate, then this crate will move or not. Okay, we have to check. But do you remember that the graph that I showed you just a minute ago? So here we know that the highest point, this highest point should be static frictional force, which is the maximum frictional forces. Until we reach the maximum frictional force, then there is no movement, there is no motion. But after the static frictional force, there is a motion. So what we need to do here is we have to check whether the frictional force, which is mu s times normal force, whether this frictional force is greater or less than. If this one is less than static frictional force, that means this one will not move. Okay, it depending on the how much normal forces we have. We can calculate the normal force in the second equation. The normal force is 80 sine 30 plus 196, which is 236 Newton. And then we can calculate static frictions, mu s n. Since mu s is 0.3 times 236, this one is 70.8 Newton. So we have a static friction, static frictional force. This one is 70.8 Newton. Okay, so if our pushing force is greater than this, then it will move. Okay, so the last equation here we can calculate the frictional force in this case because of our pulling force. That is 80 cosine 30, which is 69.3 Newton. Wait a minute. So 69.3 is greater or less? Less than the 70.8. 69.3 is less than 70.8. That means we haven't even reached the static frictional force, but it's very close. Okay, so the conclusion is, based on our calculation, we can say that the crate will not move. Okay, the crate will not move, but it's very close. You can check the answer here. The text will also calculate the distance. Okay, since this distance, which is x is a negative 0.009, very small amount, so it's in the box area, so somewhere here. So it's not tipping. Okay, it's slipping. It's slippery, slipping, but it's not tipping. But if this x is somewhere like here, it's far away from the crate, then this one will gonna be the tipping. Next question is example 8.2. Oh, we have a, is it a refrigerator? Oh, bed. Okay. Oh, bed or dump truck. Raised angle. Oh, bending machine. Okay, we have a bending machine here. It looks like a refrigerator, but anyway. We have an angle. Theta is 25 degrees. And at this time, this vending machine will begin to slide off the bed. That means this one is in impending motion. Impending motion. That means right now it's gonna be moved, but it's not moved yet, but it's going to be moved very soon. Okay, so static friction is mu s, and we have to use this equation. Determine the static coefficient of friction. Okay, we have to find static friction and normal forces. That's pretty much it, I think. Okay, let's draw the free body diagram. Since we have a 25-degree angle here, so I'd like to set up the orientation with a 25-degree. This is positive x, this is positive y. We have a vending machine. The center of gravity is here. All right. First thing first, the vending machine should have a weight. Okay. The vending machine, this one should have a weight. We don't know, but it has a weight, and there should be a normal force, right? Wait. There should be a normal force. We don't know the location, but there should be a normal force. So normal force will be, I guess it's gonna be W cosine 25, because this angle is 25. What else? Friction force. There should be a friction, because this object will move the right hand direction. The frictional force direction is opposite this direction, right? So this is the friction. I guess friction is equal to, let me see, this one is W, I guess this one, okay. this W, we can decompose this W into y-axis and x-axis, right? So this one is W sine 25. W cosine 25. Okay, that's it. Let's solve the problem. Sigma fx equals 0, sigma fy equals 0, sigma moment any point O should be equal to 0. For the x-axis, we have a positive W sine 25 minus f equals 0. Another one is vertical direction. We have a minus W cosine 25. Okay, plus normal force is equal to 0. The question was, what is the coefficient, static coefficient? Okay, so in that case, we can find F is equal to W sine 25, and the normal force is W cosine 25, and this Fs static frictional force, because this one is in impending motion, this F and this Fs is equal to same, is same. So this one mu s normal force. Since we know the W sine 25 is equal to mu s W cosine 25. So mu s is equal to sine 25 over cosine 25. That is okay, that is 0.466. Okay, this is the coefficient of static force between this bending machine and the surface. So you can check the answer here. Alright, we learned two things today. We understand the characteristics of dry frictions. The other one is we solve the frictional forces. The characteristics of dry friction is first you need to understand this equation. Static frictional force is equal to mu s times normal forces. So frictional force is pretty depending on the weight of the object, which is normal force. Okay, and we also learned that there is some impending motions. Since this pushing force and pulling force is equal to frictional force, and then once this object reaches a certain point, then it starts to move. This is force and frictions. So this highest point, we call this is static frictional force. Now this moment is impending motion. Okay, after this point, if P is greater than a certain point, then it's gonna move. So that means P is greater than static frictional force, then it's gonna be moving.